today. The reason I'm talking to you about this is because 3D printers are something we'll be seeing more and more often in our daily lives and will be integrated soon. Now, I've been working with 3D printers since I was 14 years old. I've designed and built 3 different printers, and the largest being over ½ meter in all dimensions. The main points of this speech will be about defining FDM printing for you, and the different types of movement used to deposit the material. The types will be Carteson, CoreXY, and the Delta printers. All these printers have pros and cons, but some of them are better than others. Now, first, before I can start, I need to define what FDM printing is. That stands for Fused Deposition Modeling. Now, FDM printing is depositing material layer by layer. This means that it is an additive process. The material is heated up and pushed through a nozzle of a defined hole size. The materials are then deposited on a print bed. This layer by layer process means that if you take a shaped piece of paper, it's 2D, and then you put another piece of paper on, then another piece of paper, then another piece of paper, then you have a 3D shape. If you put on enough layers, it becomes 3D. The layers are the piece of paper. Now, it does not only have to be plastics though. It can even be metal. There are printers that are printing in metal. Now, in a publishing on IEEE in 2017 by R. Kronberg and Volker Weinstroh in their publication, 3D Printed FSS, using printing filaments with enclosed metal particles. They're talking about putting metal particles in plastic filaments to change its properties. Now, this is just a basic understanding what FDM printing is. Now that I can tell you what the different ways of depositing that material. First printer design I'll be talking to you about is the Carteson printer. This printer is considered the simplest, cheapest, and most widespread printer today. It functions by moving the x-axis by the means of moving the print bed, and the y-axis by moving the print head side to side, and the z-axis moving the print head up and down. I want to show you a quick video of that. My screen doesn't turn off. And here you can see the print bed moving back and forth, side to side, but you won't be able to see the z-axis since that actually takes quite a long time, so it has to go layer by layer, but it moves the print head up and down. Now, as you can see, this printer lacks a sturdy frame. This gives up reliability and precision, but the benefit of this is that it becomes much, much cheaper for people to buy. Another problem that you can see is a print bed moving around. That is a large amount of mass. Now, this can lead to a problem called ringing. Ringing is where the printer thinks it has turned, but the mass of the bed keeps it moving in that direction. Imagine if you were like driving a truck at a high speed and you try making a corner. You can't do that at a very high speed. You have such a large moving mass that is going to end up taking you wide around that corner and you're going to mess up. Now, the Carteson printer may not be the best, but it is affordable and caters to the masses of people who do not need high precision. But for those who do, there's the CoreXY printer. CoreXY is a bit more complicated. It's a bit more complicated. 2 motors move the print head in synchronization. It moves similar to the Carteson coordinates, but it's just tilted 45 degrees. Now, this is compensated in the software so you don't see this, but the normal movements would just be turned 45 degrees. Now, the z-axis moves the bed up and down. Now, the key thing about the CoreXY is it has a solid cubic frame and a light moving mass. The light moving mass prevents the issue seen in Carteson printers. It prevents that ringing that it's like having like a Lamborghini and then turning a corner tightly. You can do that. You don't have a truck moving. And the frame improves the reliability and the repeatability of the system. However, it does drive up the cost, which does in turn drive away people from buying it. Now here's a quick video showing it. And here you can see it moving, 2 motors driving it. There are 2 belts driving. And then I'm going to show you the z-axis moving. And here you can see in the back the z-axis lowering the build plate. Now, Core XY may be a better design than the Cartesian printer, but it is still not the fastest, most precise design available today. The Delta printer is the most advanced design. It has a triangle-shaped frame. Think about it as like an upside-down cone pointing down toward the hot end. Now, it has 6 rods that are connected to the linear carriages, which are then mounted on linear rails, which are then mounted on the triangle frame. It's a little complicated to explain, so here's a quick video showing that movement. And here you can see it, the rods, and it's moving. It's all just kind of like an upside down cone, as you can see. Now, as you can see, like the hot end is a very light moving mass in this design. There's very little moving mass. So this increases the precision and the reliability of the print. But the downside of this is that due to this design concept, you lose half your build height. You have your height, but then it is divided by 2 because of the way it's designed. So you actually lose half your build height and you have a bunch of wasted space. This drives up the price to build area ratio, and that makes it more expensive than a Core XY. Another issue is the amount of computation required to generate the floating point calculations. That geometry creates complex shapes for the system and requires more computational power, and which drives up the price. In summary, FDM printing is going to be more and more prominent in the future. There are different types of material that can be used, and the Cartesian printer, while cheap, is more unreliable than the Core XY and the Delta. It can cater to the masses, but for those who desire more performance, the Core XY and the Delta are there for them. The Core XY is simpler to build than the Delta, but is slightly slower due to the higher moving mass and less motors working together. Delta is the fastest but most complex 3D printers out there, but hopefully you all learned something today about the different types of printers.